Hello guys, in this video I am going to tell you how you can solve this circuit using the mesh analysis. So when we apply the mesh analysis, then simply we need to assume the loops. So over here you can see we have two closed circuit. One is closed path, one is this, another is this. Let the current flow through this, let it be IA, and the current let it be IB. So IA and IB are the loop current. So now we need to apply the KVL in these loops. So let me also put this A, B, C, D, F. So applying KVL in loop A, B, E, and D. So over here when we apply the KVL, so simply considering, we can see that this IA current, it will flow through 3 ohm as it is. Through this loop we have two currents. One is IA, that is flowing in downward direction, and we have IB also, that is flowing in this direction. It means the current through BE, it is IA minus IB, right? I can also write the current as IB minus IA, but if I take it in this way, then the direction of the current, it is going to be changed. Means in that case the current will be in the upward direction. So it depends whether to write IA minus IB or IB minus IA. Okay, so now as we know the currents, so considering the current IA, we apply the KVL in this loop. So in this loop we also know one thing, that if the current, like over here the current direction is this, right? IA direction is this. So over here minus to plus transition is there. It means we are going to take it as negative. So I put minus 12. Over here when the current is flowing through this, so we have plus over here, minus over here, right? So we are going to take it as positive. So it will be 3IA. And then coming to this. So over here, since there is no resistance, so we are not going to put it in the KVL. So our KVL, first KVL equation, it will be simply like this, right? So because in this IA loop, in this loop, we have only one resistance, one voltage source, so we only have two terms, minus 12 plus 3IA, right? And now we will put the KVL, applying KVL in loop B, C, F, E. Now over here in this loop we have only one resistance, that is this 3 ohm, and the current direction over here, it is this, which is IB, right? So it means since there is only one resistance, we do not have any other thing, and the direction of the current is downward direction. Positive will be at the tail and negative will be at the head. So it means simply we are going to put it as 3IB equals to 0, right? So now we have two equations, this and this, and now as per second equation we can see that IB is equals to 0. So we get the first term, and from the first equation, we can get if I solve this, then it will be 3IA equals to 12, which implies IA is equals to 4 ampere. So it means I get both the currents, IA and IB. Now if I want to know the value of IS, so as you can see, IS and IA both are same, right? Because the direction of IS and IA are same. So IS is equals to IA, means the value is 4. If I want to know the value of I2, so since I2 is the current flowing through this branch BC, and this IB current is the only current that is flowing through this BC. So it means I2 is equals to IB, and since IB is 0, so we get 0 ampere. And then the I1 direction is downward, and we have seen that if in this branch BE the current flowing is IA minus IB, so I1 equals to IA minus IB, means 4 minus 0, which is 4 ampere. So the three current are 4 ampere, 0 ampere and 4 ampere. If you look at this particular circuit, let me clean up this little bit. It is this, and the current is I1, right? Now if you look at this circuit, we know that short circuit, if we have a, like you can see this BE branch over here, this BE branch, it is short circuiting this resistance, right? So it means that whatever current is coming from AB, all the current will just flow through I1 because it is a short circuit path, and all the current, like current will not go towards this side. Current will not go towards this side. Why? Because current will always follow the path of short circuit where there is minimum resistance, and since this BE branch the resistance is 0, so all the current will just pass through it, right? So at node B, when the current has two paths, one is BCF, another is BE, so current will follow the minimum resistance path, which is this, and all the current will pass through it. So logically using this logic, there should not be any current flowing through this resistance, and you can check that we also got the answer as 0, right? And whatever is IS, it is the value of I1 is same as IS, so it means we are getting a correct answer. The answer for this is 4 ampere for I1 and IS, and I2 it is 0. So with this I end this video. If you have any doubt, you can put it in the comment box. Do subscribe my channel and share this video with your friends and colleagues. Thank you.